So last time we saw the different zonations, benthic zonations of the ocean. Today we'll be seeing something of specialized relief features of oceans such as submarine ridges, guyals, canyons and ocean trenches. So for that we need to know about theory of plate tectonics. Well, to know that we need to just know something about what our Earth's core looks like. So it has a solid inner core, a liquid outer core, an atmosphere which is filled with hot magma which is liquid, and on that we have our continental crust or oceanic crust on which our continents are located. Now that is particularly the Earth's crust, which keeps on moving due to the mantle movement or due to the liquid magma movement in the atmosphere. So basically, we are staying over here on the oceanic crust or the lithosphere. We have a molten core, we have an atmosphere which is filled with liquid magma, and then we are situated or we are located on the lithosphere. On the lithosphere, we have these tectonic plates which keeps on moving either towards each other or away from each other. So this is a general map of the tectonic plates all around the world. As you can see over here, the Naxa plate and the Pacific plate the arrows which are located seen over here, they are moving away from each other. So they are diverging plates. The arrows which are shown towards the American plate and the Filipino plate or the Australian plate and the Pacific plate, they are pointed towards each other, meaning that they are moving towards each other or the converging plates. Now one question, what do you think, which landforms or which underwater forms would these convergent and divergent plates will form? Well, the answer is divergent plates form ridges or mount and convergent plates form a trench. Now how it happens, that is what we will be seeing in this video.
To understand more about plate tectonics and continental drift, we have to look deep inside the Earth. The Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which is believed to consist of rocky material so hot and under such great pressure that it is in a liquid state. The mantle, which is not as hot as the outer core and not as liquid. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this is the outermost layer of the Earth, the crust. Together, the crust and solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere. It's not always easy to see the Earth's crust. It's covered by vegetation and the oceans. But if you could drain the Earth's oceans and strip away our planet's vegetation, the Earth might look something like this. Now we can see the Earth's hard outer shell. And if you look closely, you can also see the shell is cracked. The red glowing lines mark the places where the Earth's shell is cracked into tectonic plates. Each plate carries a continent or an ocean basin, or sometimes both. The plates are moving at an average rate of 1 to 2 inches a year in a variety of directions, carrying continents and ocean basins with them. Here's why the plates are moving. Scientists believe material in the mantle is circulating much as it is doing here. The movement may be caused by heat within the mantle. You can get an idea of how heat can cause a circulating movement by watching rice as it boils. What you see happening within this beaker is similar to what's happening within the Earth's mantle. As mantle material moves, perhaps only inches a year, it causes the plates above it to move as well. In some places, plates are moving in opposite directions. They are moving apart. The area where two plates are moving apart is called a divergent boundary. In other places, plates are colliding. The area where two plates are colliding is called a convergent boundary. And in other places, plates slide past each other. This area is called a transform boundary.
So we will look at what these boundaries do and what kind of landforms they form in the next video. Thank you.